Okay, we place the watch glass here. On the top of on the watch glass, we'll place the blue dye. So we'll use steam. On heating, we won't use directly because it will undergo charring. So we'll go with the steam, so that when the steam evaporates, so that we will see the solvent evaporates. And what will be the left? What will be the left after a complete evaporation?
Blue dye.
Very good. Blue dye will be left, and after taking this blue dye from the watch glass, and by using spatula, what is spatula? The spoon which we'll use in the laboratory is called a spatula. With the help of spatula, we just scrap the blue dye and we'll collect it. So this is the general setup. This is the laboratory setup. But what I have shown you in the video is the general thing, how the evaporation takes place, and how the in live you will know that blue dye, how it is obtained, right? So what is evaporation? The phenomena of change of a liquid into vapor at any temperature below its boiling point is called evaporation. So next one, what is centrifugation? So what is centrifugation? The process of separating very fine particles from liquid by using centrifugate. The process of very fine particles from the liquids by using centrifugate. Especially the centrifugation mainly deal with colloidal solution. So these colloidal solutions are components present in the colloidal solutions are bigger than the true solutions and smaller than the colloidal solutions. But we'll see that these particles will pass through the filter paper. Because they are not that much big to present on the filter paper, they just pass through the filter paper. So to separate them by using simple filtration technique, it's highly impossible. So we'll go with the selection called centrifugation. In this centrifugation, especially, okay, so this centrifugation plays a major role in separating the components. Or it's like simple separation of cream from the fresh milk. Especially in the dairy farms. In the dairy farms, you'll get all the milk products. How will you get the milk products, children? So they'll take the fresh milk and they'll do all this centrifugation process so that the cream will be separated. If it is butter, from the butter, the cream will be separated. Okay, so by obtaining this cream, separating from the milk, toned milk, detoned milk, okay, all these things will undergo by using centrifugation. And the one more use of this centrifugation is nothing but in diagnostic centers. What do you mean by diagnostic centers? Blood samples, urine samples, they'll collect. Labs. Okay. So they'll go with the centrifugation first. So any impurities present in the blood sample or the urine sample, first they'll collect it and they'll go for the analysis. Diagnosis. Okay. Understood or not? Okay.
Yes, ma'am.
So the process of separating very fine particles from liquid by using centrifugate. Okay, this is a simple centrifugation machine. Okay, this is a simple centrifugation machine. Inside the centrifugation machine, these are the centrifugate tubes. They are exactly like test tubes, but they are not test tubes. Their diameter and the thickness is completely different. Okay, so this is a single cavity for the tubes. So they'll take the sample. If you want to test with only one sample, one centrifugate tube, to the opposite to the centrifugate tube, you need to place it what we can say standard sample, or simple water also can be taken. Why? Because when you switch on the machine, so it rotates more than 6,000 times in few minutes, that much fast. So in order to not to break the centrifugating tubes or to imbalance it, so to make it get balanced, so that they'll place the another centrifugate tube with water. Understood or not, Bhumika? Yes? Yes or no? So they just take this centrifugation tubes. So have you seen that centrifugating machine out there? And you'll be having manual one also. You'll fit to the table by using screw. With the help of hand, by how we'll spun the yarn. Have you seen anything? So the same way when we are rotating the thing, there also the tubes rotates manually. Both will be present in any laboratory. Okay, one is by using electricity and the other one is by using manual. What is the main principle? Anna?
That it is spun rapidly so that the dense particles come at the bottom.
Density is the main principle in this centrifugation.
Okay.
Less denser thing will be present at the top and high denser thing will be present at the bottom. This is to separate the two denser components present in the solution. Understood? So when we spun rapidly, the separation by using this density also depends upon that spinning. If the rapid spinning takes place, then only we can see the fine particles will be settling at the bottom. Okay, so have you seen that rotors, the cavities inside the centrifuge machine, centrifugate tubes? Okay, all this. So I think it's clear. Yes or no? Yes. Bhumika, is there any network issue here? What happened? Okay. So next one is separating funnel. So what do you mean by this is one of the kind of separation techniques? The name of the separation technique is mainly based upon the apparatus which we use. Okay. So here immiscible liquids. What are the immiscible liquids? So the liquids, when it is mixed up, 2 or 3 liquids are mixed up. So when the liquids are mixed up, so that we can easily differentiate the layers or the phases, then it is considered as immiscible liquids. Example, kerosene and oil or any oil and water, organic liquids and water, all this considered as organic and inorganic liquids mixed up. So all this considered as separating funnel. Here also it is also depends upon the density. Here the heavier denser one will be present at the bottom of the separating funnel. This is the separating funnel. We can see two different layers. Oil is less denser than water, so it floats on the surface of water. And water is heavier than oil, so it is present at the bottom, right? So when we have taken it, we need to clamp the separating funnel and we leave the separating funnel more than 20 to 40 minutes. So if it is not possible in the class to do this experiment, so what we need to do? We need to take hold of this separating funnel by holding the lid. This is called lid and this is knob which can be used for opening and closing. Okay, this is nozzle and outlet for the separating funnel. So by using the separating funnel, we need to hold the separating funnel like this. You need to place the thumb finger like left one, and with the help of this right hand, we need to shake like this. This is the separating technique to hold the apparatus. We should know that. Test tube also, we need to hold the test tube like this. We shouldn't hold the test tube like this or like this. This is wrong. How to hold the test tube, children? Like this. If we want to tilt it, we need to tilt like this. We can't do like this because if it is acidic in nature, so there is a chance of burning. And if any impurities are present in your hand, they may react with the solution. So how to hold the test tube? Like this. Okay, and the separating funnel by using like this, by holding the bottom of the flask, we need to shake like this. So if we shake for 5 to 10 minutes, definitely the entire components will be separated into two different phases. Okay, heavier one will be present at the bottom and lighter one will be present at the top. So when you open this knob from the nozzle, this bottom one will be separated. We need to collect the bottom one in one of the beaker. And what will be the leftover? Next layer. So that also can be separated in a separate beaker. So the two different components present in that immiscible liquids can be separated by using simple separating funnel. Any doubts? Any doubts?
No, ma'am.
No? I'll show you this video. Let me complete with the separating techniques and then I'll show you the video. Okay? So what are the applications to separate the mixtures of oil? Next one, extraction of iron from its ore. Here also it converts into solution form. If any impurities are there, they'll be settled at the bottom. So remaining will be separated by using simple separating funnel. Okay. Sublimation. What do you mean by sublimation? Sublimation is used to separate the salts in that one of the salt is, it should be like sublimized salt. That means here when you heat the sample, the solid should convert into gaseous state without undergoing any intermediate stage like liquid. Understood? Solid can be separated into solid can be undergoing into the gaseous state without undergoing the intermediate state, that is liquid state, is called sublimation. Sublimation can be separated two completely mixed up salts. Among the two salts, one of the salts should be sublimized salt. Then only we can separate this sublimation. Okay, for example, table salt is mixed up with ammonium chloride. Table salt mixed up with ammonium chloride. In this both are salts. Both resembles exactly the same. We can't differentiate it until and unless we know the sample from the laboratory. We should not taste it, right? So that here ammonium chloride is a sublimized salt. Understood? It's a sublimized salt. Okay, so that we can go for sublimation process. Especially in the sublimation process, have you seen the setup? Have you seen the setup? Lower one is called Chena dish. We'll take the sample in the Chena dish, that the two salts or sand or ammonium chloride, and we'll place the funnel invertedly. So this inverted funnel, and we need to clamp a cotton plug at the top. This is the cotton plug. Why to place the cotton plug at the top? This cotton plug won't release the energy from the funnel or won't allows the energy to pass through the funnel. Okay, so when you heat continuously, what happened? Among the two salt solution, one of the salt solution is a sublimized solution, sublimized mixture. So that mixture, remaining salt will be exactly in that China dish only. But the sublimized salts, when it is observed the heat, it gradually converted into gaseous state, and these vapors will adhere to the walls of the funnel. After some time, we feel that entire sublimation is finished. After some time, after cooling, we just take out the funnel after cooling, and we can see that the vapors are converting into again solid. So it's like a vice versa process, solid to gas, and again on heating. This is on heating. On cooling, gas to solid, again you'll get solid back from the gaseous vapors and scrap it. So that you will get one of the salt, that is sublimized salts, will become separated by with the mixture. Okay, so the salt which obtained after sublimation is the purest one. When we compare the purity after sublimation, it's the salt obtained after sublimation is very much pure. Understood? Understood or not? This is about sublimation. Any doubts, children? Bhumi and Anna?
No doubt, ma'am.
No? Okay. Next, this is about sublimation. Next. So what are the sublimized salt? Ammonium chloride, camphor, naphthalene, anthracene, solid, CO2. All these are the examples of sublimized salt. Only sublimized salt will be converted into solid to gas, gas to solid, but no other salts will undergo this. This separation technique is only meant for sublimized samples which are present in the mixture. Right? Next. Chromatography. What do you mean by chromatography? Chromatography is a kind of separation technique, especially when if the sample is colored sample. The colored samples only by seeing the colored samples only we need to select this chromatography. Chroma means color according to Greek, and graphy means writing or the study. Writing or study. It's nothing but chromatography. Understood or not? So when we go with the chromatography technique, here especially there are many chromatographic techniques like high performance liquid chromatography, liquid chromatography, gas chromatography, high performance gas chromatography. All this you learn in your higher classes, but especially according to your standard 9, there is only one particular chromatography, that is paper chromatography. Okay, so according to the paper chromatography, here the paper is used that is nothing but cellulose paper, not the simple filter paper. It's nothing but Wattman paper. Wattman paper is a kind of filter paper. This is having high efficiency. Okay, Bhumika. Well, what happened? What happened, Bhumika? I thought you are having doubt. So this is paper chromatography, and this paper chromatography, we can see that the filter paper and this filter paper will take this here especially by using black ink. We feel that the black ink consists of only black dye, but the black dye itself, it's a combination of many colors. To separate to know what colors are present in that black dye, we use this paper chromatography. This is the general setup. This is the laboratory technique. These are nothing but clamp, and this is the chromatographic paper. It's nothing but what? Filter paper. It's Wattman number paper. And we just draw two lines. One is the initial line, frontal line. Okay. And the end line. On the top of the first line and the lower line, we just drop 2 or 3 drops of black ink. And we need to dip by using this clamp, we need to just hang or dip the paper containing this black ink, drops of black ink, in a solvent. Solvent, maybe it's of water or any other chemical. In such a way that only the tip of the paper should touch the solution, not entirely dipping entire thing in the water. So due to this like chromatographic paper is having ability to observe the water, when they observe the water, these black ink also observes the water, and they transfer from the first line to the end line. When they are transferring, so here the main principle is ability to hold. So if it is having affinity, less affinity one will be present at starting, and which is having more affinity, strongness towards the dye will be present at the last. So we can see that solvent front, and these are the different components present in the black ink. Understood or not? Any doubts?
So ma'am, there is special type of paper for paper chromatography.
Yeah. Wattman number paper will use shell.
Yes ma'am.
Wattman number 45, Wattman number 90. These are the different kinds of filter papers used in the laboratory, especially for the paper chromatography. It's a cellulose paper, but it's much effective than the normal filter paper. And the thickness also very much thick when we compare to filter paper. Right?